So for the final episode, I have enhanced interpolation. At least the final episode for the time being. Maybe we'll expand this later on, especially when people start actually completing the course and figuring out what I did wrong, telling me so I can improve as well. So there is the potential we continue this course, but for this whole big block, this will be the last episode. So why am I mentioning enhanced interpolation? Well, if we look at our game over on our Linode server currently, you're going to notice, let's say I think I'm selected, okay, yeah. Over here, I am the blue player, right? And it looks pretty decent with client-side prediction and server reconciliation. But over here, when another player is viewing our player move around, there is definitely some lag and some jank going on, especially when I start moving in multiple directions, and things just aren't that great. And I believe this is due to the way we are currently handling player interpolation. Might have made a small mistake, I have to admit, when we are using GSAP to move our player. So we're really only interpolating every, 15 milliseconds, and that's really not enough time to show any smooth movement between point A and point B. Another issue is it's not guaranteed that every new backend player position with X and Y is going to be returned at the rate of 0.015 seconds, because we're always going to be getting latency and delay from the server, so there's the potential a request comes in later at about, I don't know, 1 second. And if we're only interpolating within the time span of 15 milliseconds for a distance that was actually covered within the span of a second, we could have had multiple requests happen during that time, we're going to get that jank jitter effect. So I found a solution for this. I believe it works pretty well. We do have to do a little bit of rework on client-side prediction, but I think this is a good way to get your game working and give you an end product that actually moves well for all players. So going back to do, the first thing we're going to complete is determine the player's target position and update players. So we can get rid of this else statement in which we're currently interpolating all other players with GSAP. We're no longer going to do things that way. And now what we're going to do is add in a target position for all of our players to be traveling to. So whenever we get some sort of player position from the backend, we're going to store it as that player's target position rather than immediately moving them as soon as we receive the response. And then once we get inside of our animation loop, we are going to ease to that target by using a linear interpolation formula. And we'll get there, but first let's go ahead and store that target. So I want to store the target to our front-end player, which we're currently looping over. We know we can get that with front-end player's ID. So right beneath where we're doing all the sorting for our leaderboard, I will select the current player and add in a target property, which is going to have an X, and then it's also going to have a Y. What is this going to be equal to? Well, simply the backend player X, and then the backend player Y, which we want our player to actually move to, but we want them to move to that slowly, smoothly, that is. Now, down below where we are applying server reconciliation, we can leave most of this intact. But we don't need to set our front-end players X and Y immediately anymore. We can get rid of that. We do want to keep this other code to take into account server requests that might not have been processed. But instead of adding on to the current X and Y position of our player and immediately moving them, we are going to now add on to the player's target. So we have target X and target Y. So we have this target X and we have this target Y, but we're not actually moving our player at all just yet, or at least other players who depend upon this value. So instead of just immediately moving players to backend player X and backend player Y, we're now going to interpolate to those new positions. And to interpolate to those new positions, we want to scroll down to our animation loop where we're looping over all of our front-end players. So right here, we want to say if our front-end player that we're currently looping over has a target property associated with it, then we want to grab that specific front-end player by referencing our main object. We can get that specific player by passing through the ID right here. And then we want to affect their X coordinate first. So we're always going to be adding onto this some specific value, and this is going to be an interpolated value depending on the front-end player's current position and the target in which we're trying to go to. So to illustrate this, let's say that our player is currently positioned at an X position of 0. And then we have a target position over here of 5. What we want to do is get the distance between these 2 points to start. So we would get the target distance, which would be 5. From that, we would subtract the original distance, which would be 0. And that's going to leave us with a product of 5. Simple enough. But what we're going to do is multiply this by a linear interpolation value. And that's going to be any number 0 to 1. So if I multiply this by a value of 0.5, this means for every frame, we're actually only going to move our player by what? 2.5 pixels. As a result, let's say, I don't know, that this blue circle is our actual player, and when we apply this movement with this linear interpolation code, at first we only move by 2.5 pixels. And we're going to do the exact same thing until we get to our destination point, and our server sends over a new target value. And the target value might be somewhere over here at a value of 10. What do we do next? We go through the whole process again. 10 minus our current value of 5 will be equal to 5. We want to multiply that by the interpolation rate. It'll give us 2.5. We move over once, we move over twice, and we're going to get to the end destination right there. So previously, before all this interpolation code, we were just going from 0 to 5, but using linear interpolation, we're going to be able to calculate the distance no matter how large it is. It could be 0 to 5, 0 to 10, and then based off that, we are going to multiply it by some value. 0.5, I think, is a good value to start. And then that's going to move our player on the front end by basically half that distance until we reach our actual destination. It's going to smooth things out. So we go from here to here to here instead of just from here to here. Adds one frame in between on the visual side. So that's the general idea. We want to get the distance between our current x coordinate and the target coordinate. So let's grab the target coordinate with front end player's ID, target x, and we're going to subtract front end player's ID dot x. That'll give us the distance, and then we need to multiply this by some linear interpolation value, which I think 0.5 is a good one. You don't want to go too low here unless you compensate for this delay over in the back end, because if you do something like 0.1, that means it's going to take basically 10 times the amount of time it would take for you to get from point A to point B. And if it's taking you 10 times longer to get from point A to point B, your collision detection is going to be off on the back end, because that is the single source of truth in which we're referencing all of our collisions from. But when we do something like 0.5, we're really only taking 2 times as long to get there. We're really only adding 1 extra frame in between our distance, and we're not going to be able to really tell that the collisions are slightly off in this case. So I think this is a good value with 0.5. And we want to do the same thing for our y coordinate. So I'm going to select our front end player's ID, but on the y coordinate, we can just basically duplicate this line anyways. Save ourselves some time. Replace x with y for our actual position, and then our target, and then over here when we calculate the distance. And that's pretty much all we need to do to add in linear interpolation for the other players. So let's save this and test it out. I'm going to go over to localhost 3000, node mod should automatically refresh it, and then I will add in some sort of username, hit start for both players, and we should see things be a lot smoother on one of the browsers. And it might be a little hard to tell, but it definitely is smoother over here on the left. If you want to really see the result of linear interpolation, you can turn this down to something like 0.1 or even lower. Save and refresh on both screens. And now, you can see there definitely is some sort of little drag effect right here for this player. But the delay is too much between our actual position and what other people see. So if this player right here were to run into some sort of projectile, it would look off, because we would calculate that the two collided on the back end based off this actual position, but it would look like that they never hit the projectile in the first place. So that's why I'm using a value of 0.5 instead of 0.1. Now, if you're not completely happy that some players might see you differently compared to what you see over here on your screen, there is one thing you can do, and it's pretty much just take out client-side prediction. If you're confident that your server is going to be running quite well, and you don't need the extra bit of responsiveness, in regards to immediately moving your player when you press an input. You can just take that client-side prediction where we moved our front-end player's X and Y coordinates whenever they press down a key, comment it out, save, refresh, start a new game, bring in a player, and now we have basically the exact same movement on both browser windows. So the linear interpolation is there, and this is going to look a lot better when we actually push this live and start getting delay integrated into our game. But I know I want to fine-tune things a little further. What do I want to do? I just want to slow down our movement a little bit. I think it's quite fast. And to do that, we need to find our speed constant on both the front end and also the back end. For me, that is on line 176. I'm going to half this to 5. Go over to our back end, find our speed constant, half it to 5. Make sure that this works. And now I think that's what I'm going to keep. You can pretty much just fine-tune this to taste, but I like that. I don't want players just immediately buzzing around and dodging every projectile that comes at them. And one more thing that I know I'm going to need to fix because I was experimenting with this earlier and I found a bug is when we have a sequence number right here on keydown, if a player gets removed and they try keying down and they just don't exist right here with backend player socket ID, we're trying to reference sequence number even when they key down on the back end, and that's going to throw a backend error. So as a result, we want to prevent this code from being run if the backend player pressing down a key doesn't exist. So we'll select our backend players, get socket ID, and say if this does not exist by adding in a bang operator, then what do we want to do? We want to return so we don't run any of the following code. So one more quick save and refresh. And I really like how smooth that is looking for our player. So the final test here is to push this up to our server. I don't believe I showed you how to do this, so we will do that right now. I'm going to go over to Warp, and I'm going to make a new git commit right here. So if I type git log, you can see the last commit I made was for the last video. It was game polish. I want to add all my files, which are currently in staging. So if I do git status, you can see that these files are actually waiting to go to staging. So to add them to staging, I'll do git add all with a dot. And then to make a git commit, we can type git commit -m quotations enhanced interpolation. And I actually already have a commit right here, which I misnamed, which I did off screen, so don't even worry about this. If I want to amend this commit name, I could do git commit -- amend. Change this within the editor vi. I don't want ASD, I want enhanced interpolation. Save out of this with :WQ. I know Vim is confusing, but that is going to give us the correct commit name. If I type git log, you see there it is. It's ready to be pushed up to git. I can type git to push. And I actually need to do a git push with force because I've been testing things out on the server and I know this is a commit I want to push up for this episode. So finally I can do a git log and we know this is correct. It's up on the server, and now we want to go over to our Linode Akamai server and make sure that we're pulling down this new commit that we pushed up. So I want to SSH back into our server. Mine is root at 139.144.247. It's going to log me in automatically. You may need the password. But once I'm in, I want to cd into our multiplayer game directory, and then I want to type git pull to pull in those new changes. So you can see I made 4 changes to backend.js and 41 to frontend.js. So things won't take effect until we actually restart our server, and we can restart our server with PM2, restart, and then the ID name, which I know is 0. If you ever need to find out your ID name, you can type PM2 list. That'll give you a list of all the processes currently running with PM2. So the ID is right here. I know mine is 0. That's why I typed PM2 restart 0. But once you do that, now you should be able to go over to your website and refresh, and it should have all those new changes. So if I make player 1 right here, and I start moving around, you can see that is already much more smooth compared to what we had prior. And I can create another player over here, bring them into the screen, and we have much smoother movement all around. So we definitely enhanced our player movement. You can see the collision detection is still pretty precise, I would say, for the most part. Even with that linear interpolation, maybe there's just like a small gap in between the two. But I'm sure that's something that you guys will help me figure out in the future, because I'm not the best at multiplayer games, but I know that I've researched a ton. And this is a good way to get something up and running. So that's going to be it for the basics of the multiplayer game. Let's go ahead and admire the results. Now obviously this teaches you the basics of networking within the realm of JavaScript, but I would say if you want to take this to the next level, I have a complete premium course related to this game on how to add different kinds of player movements, how to add enemies, different background elements, and so forth to really make your game stand out. I would really recommend trying that to add more and more into this game and see how you can take it to the next level. So to get started with that, be sure to click this video right here.